Well, hi, good morning, and thank you so much for joining me in my shop here on April 17th. It's been a couple days since I've been in my shop, and that's because of the fantastic summer-like weather we've had the last couple of days. Today it's a little cold out there. It's only 7 degrees and rainy, a little more typical for this time of year. But the last couple of days, the temperature's been summer-like. It's just been fantastic. So I don't want to be in my shop here when the weather's beautiful like that. In fact, at the end of the last summer last year, I look back on what I did during the summer, and I spent too much time in the shop here. I need to spend more time outside. So that's what's going to happen this summer. As the weather gets better, my videos will get a little more sparse, or maybe short. Maybe I'll do more short videos or something. I don't know. But anyway, here I am. What am I going to do with this radio? Oh my gosh. One thing I did do while I was sitting out in the sun is study this schematic for a long time. About an hour staring at the schematic for this radio. Strikes me that there's two problems in here. One is the motorboating problem, or exhibits itself as motorboating in the speaker. And the other one is, I think, poor performance. Which of these do I want to go after? I think I want to go after the motorboating problem. Now, one of the things about this radio is it has always had fantastic sound, fantastic tone to listen to. Don't really know exactly why, but somehow this produces a really nice tone. It has a tone control on the front, which unlike most radios is actually a snap switch. And to a large degree, what's going on here, there's two phono settings, phono high tone, phono low tone, something like that, and then 4 more settings, and then an off switch. Four settings, 4 tonal settings for this radio. How did they achieve this? Through a complex network of capacitors. So this is a look at the switches here that are shown. We're looking at this switch. There's 2 separate sections and a side, 4 sides. One side, the other side, and then this side. So four sides. They've spread them out here. And then I've got a little bit of a zoomed up image of them. And these check marks are all from a couple years ago when I worked on this radio, and I went through component by component, wire by wire, trying to figure out if there was a problem with these switch wiring. And I believe in the end I did think I found out a problem, but I can't remember fully. And just to add to the confusion, the layout of these components, or the switch wafers, is not done A, B, C, D. Instead, you can see down here where I've drawn it A, B, C, and D. This is A, B, C, and D. But on the diagram, they're laid out B, A, C, and D. It took me a while to figure even that out. Not this time around, but the last time around. So lots of confusion looking at these switches. So how are they doing tone with all these switches? Well, they're using feedback to control the tone. That's what I would come to conclude in the way this is wired. Now, I know this is a little hard to look at on the camera, so you don't need to stare too closely at it. But coming from the speaker, right from the speaker, is a wire. I've colored it blue here. Which comes down, gets just below the heavy B- line they've drawn on the diagram. See it just popping below here. Travels over. It's all colored blue, although it's hard to see. And comes up and gets into the bottom of the volume control. They've hooked one line from a speaker into the bottom of the volume control. Now, usually the bottom of the volume control is tied to, well, maybe this line. B-. There might be a resistor in there or something, who knows. But often just directly down. But this one, it doesn't connect there. Well, it connects to the output of the speaker, and the output of the speaker is on the other side of the output transformer. Isn't this all a little weird? The answer is yeah. This is part of the radio that engineers love to fiddle around with. This is the part that really controls the tonal quality of the sound coming out of the speaker. And I found that lots of engineers really go busy in this area and do crazy things. Sometimes not. Sometimes just a simple capacitor and a variable resistor gives you a treble cut. That's the tone control, and that's the end of it. Sounds kind of North American to me. But their approaches can be taken to control the tone of a radio, especially if your intention is to boost some of the frequencies. So maybe boost up the bass. Well, you can't boost up the bass with passive components. All you can kind of do is just reduce things, reduce the treble, reduce the bass. There's some other tricks that can be played, so you can have these things emphasized coming out of the radio somehow. I don't know. In this case, using feedback. Using feedback, part of the signal, or a sample if you like, of the signal, sample's not a very good word for it, is actually fed back to where? Bottom of the volume control. From there, it's heading to the grid of the preamp tube. Now wait a minute. Isn't that going to make the radio squeal? I mean, this is like feedback. This is like holding the microphone too close to the speaker and having the sound go back and come through again. And you get a feedback. If you do it with positive feedback, if you have a positive feedback arrangement. You know, when you have feedback with a microphone and you move the microphone, maybe you've never done this, I certainly did it a lot as a kid. You move the microphone closer to the speaker, or maybe when the feedback starts, you yank the microphone away from the speaker, and you get all kinds of different tone pitches happening because the amount of negative and positive feedback from the wave in the air is varying as you pull back the microphone. And so in the case where there's a positive feedback, you're going to hear a squeal, and where the feedback's negative, you won't hear anything. You won't notice anything. So this uses a negative feedback. Now what for? Oh, isn't that a sense of negative feedback? Isn't that just going to quiet down the radio? I mean, it's almost like having a leak. The sound's leaking out of the speaker and sneaking back into the early part. Well, here's the interesting thing. If you have a nice, let's say a beautiful sine wave going into this tube, on the grid on this tube, and the beautiful sine wave goes through these circuits and through this tube, but by the time it gets to the speaker, it's no longer a beautiful sine wave. It's been distorted a bit, one way or another. If you take a bit of the negative feedback, or take a bit of feedback negatively, okay, I think you know what I mean, from the speaker, and carefully shove it back into the grid, it will compensate for the error in the signal that's developed as it's passed through. So you have the distorted signal. You could think of the distortion as an error, and you can grab the error and stick it back into the beginning and actually compensate for the error. Now, offhand, this is a weird sounding thing. Well, if you compensate for the error, there's no error left here. Well, that's exactly what happens. The amount of distortion can be greatly reduced by using a little bit of negative feedback. This trick is used on all kinds of amplifiers. It's nothing mysterious. It's not specific to this radio by any means. Technique used all over the place. Now, what if you manipulate the feedback? Filter it with capacitors, phase shift it a little bit, do something different with the treble part from the bass part. You can affect the tone quality dramatically coming out of the speaker, including bass boosting and other stuff you can achieve this way. Ultimately, I suppose you're reducing the output a little bit, but you just turn the volume up a little bit and there you are. You've got it all back. So that's negative feedback. Very powerful way to reduce distortion. Now, how much distortion can you hear? It depends on the kind of distortion, but if it's kind of musical distortion, harmonic distortion, you're not very sensitive to it, especially with complex sound. So someone's voice or music playing from many instruments, like a band or something like that, you really can't pick up on the distortion. It's just lost in all the sound. Sine wave, yeah, maybe on a sine wave you can hear a few percent. The most modern amplifiers, the harmonic distortion, as compared to the input signal is something crazy like 0.1%. It's way below anything that would bother you, unless you're sending pure tones. Maybe you could hear it. Maybe you would realize it. The pure tone came through, like a sine wave or something like that. So what this guy's done with this radio is he's created a series of filters or adjustments based on the capacitors you see here. They're all over the place. And switching it in different ways through these capacitors to maybe phase shift the feedback to create the tonal effects that the engineer was interested in. And I gotta wonder now, did some engineer sit down with a piece of paper and a pencil, calculate all this out and come up with this? I kind of doubt it. I think it's much more likely that they did some of that, and then they mocked up the circuit, and then they messed around and messed around and mocked up and messed around, and finally got something they were pretty happy with. And that's what's in this radio. So now I've studied this so much a couple years ago and just yesterday too, studying this thing, and I don't think I'm ever going to really conclude exactly what has gone on here. Exactly how this is supposed to work. Studying these switches just drive anybody nuts. I'd have to make multiple diagrams of every position of every switch and all this kind of stuff. And I'm a little too lazy to do that. Because I think there's probably another approach. I don't really need to understand this fully. I need to do something about the fact that this component, the volume control, is not the original in this radio. I replaced it. Now that's a really critical component in this whole thing. It's not an ordinary volume control. It's got a tap on it. The tap, in fact, you can go through it, gets onto the feedback also. The tap is affected by feedback, but the tap also has a resistor going down to B minus. So in a sense, the bottom of the volume control is in the middle. And this little piece here, well, I don't know what to say about it, but that's where the negative feedback is coming fixed. It's fixed here. Oh, that's interesting, Jim. I hadn't noticed that. I hadn't realized that. It's just a wire. It's fixed. And how much of this am I misunderstanding? Well, that's a tough question for any of us to answer, right? What is it I believe that isn't true? That's a tough question. So I've learned to doubt myself an awful lot. I guess as you get older, you get smarter and realize you don't know anything. That's kind of how it goes. Yeah, smart people know they don't know anything. So probably the problem, and I hunted and hunted for a component error or some kind of error in here. I've had this radio since I was a teenager. I have fiddled with it. Goodness knows I don't remember what fiddling I did now. So I may have made a mistake in it. I don't know. I don't think so. I think it's all been corrected by my previous session. But I could not get rid of the motorboating. Motorboating is a sign of feedback. So I gotta guess. This volume control is responsible for the feedback problem in the radio. It's not the components. It's not the switches. It's not anything. It's not wiring. It's actual volume control. Now I don't have a volume control to replace the replacement with. I was lucky enough to have this, even though it's motorboating. So the real question I'm facing now with this radio is, since I don't think I have the component to restore it to its intended operation, I'm gonna have to come up with my own version of this. Oh, that's a bad thing, because I am not a radio design engineer. So that's what I'm thinking about now. What are my options? What can I do with this volume control? What steps can I take? How can I investigate and make it clearer to me how this is operating in terms of the feedback? How can I realize what change I need to make in the radio to enable this motorboating to stop? And what are my options? And one of them is to completely remove the feedback. Just cut the wire going to the bottom of the volume control. Just cut the feedback right out. Goodbye to all the feedback. Maybe I'd have to cut it up here to really cut it off. I don't know. Okay, time for coffee. That's for sure. I talked for 15 minutes. Oh my gosh. I'm sorry about that. Okay, scratching my head while I drink my coffee. That takes coordination, you know. I'm going to take an experimental approach here, and the most I can do is, disconnect things at first. I'm going to try to make new connections. I'm just going to try to disconnect stuff. Why not disconnect all the feedback? Well, I think that's a big mistake. All the feedback. If I were to break this wire here so there's no feedback, I don't know what the result would be. But somehow I think that's probably going too far too fast. Another option is to break away a little bit of the feedback. So this feedback line comes down, continues, goes into this switch, capacitor here, resistor there, complicated switch arrangement, kind of combining these things in different ways. What if I eliminate this? The problem with motorboating occurs when the volume control is at its extremes. So this is the volume control, this upper one. The lower one is fixed. This is a tap. This lower one doesn't move. So this upper one goes right to the top for full volume. It comes down. It will actually cross this point where this tap is and then continue on to the bottom. As it crosses this point, or somewhere near this point, the radio starts to motorboat. Well, maybe if I get rid of this, maybe, by simply breaking this wire or this wire somewhere, so that there is no feedback coming up through here, maybe that'll resolve some of the stuff. Maybe it'll resolve all of it. I don't know. The other thing too is I don't remember experimenting enough with the actual tone control. Setting it recently, the last time I had the radio playing, trying different tone control positions and then seeing what the feedback is. So maybe that's the very first thing, because that's the least impactful thing I can do. If you cut a wire, you might have to solder it back. At least I just have to rotate the switch here. Okay, so we're going to turn this guy on. Here he goes. It didn't come on. Oh, I know why. Let's try that again. There we go. Okay, I've switched it on with the dim bulbs just because I'm a little nervous. My scout patch here keeps interfering with seeing the light. Joda. Yeah, I did a Joda. Jamboree on the Air. Yeah, I actually did one. Something funny happened at it, which I won't go into. But there's an interesting story. I'm gonna stick it over here. Okay, radio, are you warmed up? Well, I think I need to hook up a speaker. I think that's also missing here. Here. Okay, volume down. Oh, the speaker is connected. That's why I couldn't find the leads. The speaker is connected. Why are we not hearing anything? Oh, there is. There's a faint hum there. Very, very faint hum. Oh, I think I probably know why. 79 volts. Hey, there we go. Okay, everything's happening now. Turn the volume low, and we get that lovely sound. Turn the volume high, we get a different version of it. Okay, so now we're on the first tone setting, next tone setting. So the upper one is gone. Lower one remains. Next tone setting, lower one remains. Oh, I can play this like an instrument. And the next tone setting. Full volume. No volume. Okay, so that didn't reveal too much. I suppose I could spend the rest of today trying to analyze the effect of the different settings here, but no, I'm not going to do that. I'm not going to do that. Instead, I am going to go ahead. Since we get this when I turn the volume right down, that seems to me to have something to do with the slider and the volume control crossing the tap point. And that's where this feedback's coming in. So I'm going to eliminate this feedback. So here we go on that. So this is D right at the front. So this one's right at the front, right up in here. And there is a wire. Oh my gosh, I'm not going to do this. I'm going to have to figure this out off camera because this will go on for ages. There is a wire coming into here. This wire. I have to find that wire right there. What's that? What's that thing? So you see, these two wires are actually coming from the same place. Oh, so there's another feedback wire over here. Oh boy. Well, where's this one going? This one's. Oh man. Oh my. So these switch wafers have different purposes, as far as I can figure out. This one, for instance, is turning on and off the B plus to the screens of the front tubes. The idea is when you have this thing set to phono, the B plus is cut off. So these front tubes, radio tubes, just stop working. So that's all that's doing. And next one over. Let's go to this one. We'll go to this one. Can you see it says PU there? Pickup. So this is the input for your phono cartridge. Comes down along this line and goes into this switch. This switch selects between the input being here or the input coming from the radio output. So that's what's going on here. If you notice, there's capacitors involved. The engineers finagled everything in this radio, in this part of the radio. It's all finagled. This guy here, I'm trying to remember now what it was. See, it goes up. It's connected to the back of the sliding part of the volume control. It's down in here. You know what? I can't remember now. Here's the B minus coming in here. Yeah, I don't know. Yeah, I don't want to spend another hour and a half trying to sort this out. So anyway, suffice it to say, each of these wafers kind of has a different job, although both of these are dealing with this feedback manipulation. At least that's what I got in my head. I mean, I have to tell myself that I could misunderstand this totally, or there could be much more to it that I'm not picking up on. So okay, so all we got to do is just find this wire and eliminate it. I can find the wire on the way out because yeah, it's just one wire leaving, one wire coming in, one wire going out. This resistor here is sitting here. I can find this resistor. In fact, it's probably this one right up here. Ooh, this radio is still on. Careful with your finger there, Jim. A20. Now look at this. This is really a nice schematic. First, they have a component map up here. You can see the different types of components. Condensers, capacitors by modern name, resistances, inductances. So all the capacitances are written along this top line. And they're shown where their position is in the radio. Now, I mean, you may be familiar with this, but maybe not. Not many schematics do this. Some do, though. And so if you want to know where C7 is, you'd look for C7. And C7 must be somewhere down in this area. Whoops, not down here. There it is, C7 right there. So this helps you find the components. You can go from here to there through the chart. Very, very interesting. Now the chart, here's just the component chart here. we want to know about this R20. R20. So here's the resistors here. R20. 33. I think it's K. 33K ohms. And if we look, there he is, right there. Okay, so there. So that's the resistor. Got a wire on it. Look, there's a red wire coming up from the far side of the resistor, which incidentally has a capacitor on it. But you see the capacitor, probably this capacitor right here. That wire comes up to here. Oh, there's another one. So it comes up to this tab, or it would represent this part on the volume control here. This takeoff part on the volume control. And there's a resistor coming from it. There's another resistor coming from it here, and that's a red orange. So it's a 22K. So the resistor coming from it, so I'm going to lose my head here, is R. Well, I think that says 9. Yeah, R9, 8, 9, 10, R9, R9. It's worth checking these things a little bit. 22K, so that would be red, orange, that's what's there. We cut this wire, we eliminate the feedback. Wait a minute, we're only going to eliminate the feedback. Yeah, eliminate the feedback from here, but we'll leave this resistor in place. Very, very important. Let's try it. So we're going to desolder that red wire and pull it out of there. That's how I want to do it. So I posted a very short video last night of some air traffic control over the Atlantic Ocean. Perhaps if you watch my videos, you probably watch that because it's very, very short. And that's what I've been doing quite a bit of lately. I found with the SDR, it's particularly easy to do this. I mean, the frequencies are known that the air traffic control goes on. You can look it up on the internet fairly easily. It varies with what day it is and what time of day and stuff like that. But there's easy to get. Pilots have to know this information, so it's easily obtainable. So you get the list of frequencies, but you don't know which one they're using necessarily, and you don't know which one is receivable. So if you look on the SDR display, the waterfall display, and maybe you're looking from, let's just 8 megahertz to 9 megahertz. And you see stuff coming down, noise signals and that. And then you'll see something appear for a while and then disappear. That is potentially some kind of signal like air traffic control. Anyway, I won't go into it any further. I'm just trying to encourage the it. Oh boy. This radio's on, Jim. Oh my God. Oh boy, oh boy, oh boy, oh boy, oh boy, oh boy. No sound coming out of the speaker, no lights visible, no tubes visible. I got fooled here. Very lucky. I'm lucky. I could have done something really stupid. You know, not just stupid, but really stupid. And I don't think this is going to come off so easily. I don't want to cut the wire because I'm probably going to have to put it back in right after I finish this. Yeah, one of the beauties of this radio is its tone quality. It's just wonderful to listen to. This is actually a really good. This was my high school shortwave radio. And wonderful sound on it. Okay, so I've disconnected the wire. It can hang out there, no consequence. Here we go. Volume is set in the, let's call it the neutral zone. Let me put the antenna on it. Being just Mr. Hopeful, but I think a little more sound input might be welcome. Oh, still doesn't. To get rid of it at the top, it had the opposite effect. So I just want this to be on. This is on the broadcast band, which I believe is pretty loud. Ooh, we're not doing well at all here. Did that completely kill the sound? I should have made the radio work a little better before. Oh no. Jimmy, you're all lost. Okay, wrong switch for the band. First of all, this is the band switch. Okay, volume down. Now it's back on the low volume. I thought oh, that's right. I got rid of it on the high volume, but I don't want to test it. Well, we can go on a short wave band. They're kind of weak. You hear a tonal change as you got the volume up pretty high, but it's not significant. Sound okay to me, except for this bump, bump, bump at the low volume setting. So I missed it. I missed it, or did I? Maybe I need to set this somewhere else. Is this still having a tone effect? Volume down. That's phono. Some of those sudden sharp noises, I think, are actual interference signals. I don't think it was a radio. Oh, maybe that's crap. Well, there you go. I thought I'd solve the problem at the lower end of the volume setting, and instead it's the upper end. Okay, what more damage can we do? So we think there's no more effect coming from here. There's a continuous wire feeding back into the bottom of the volume control. There's something happening here up to here. Here up to here. I think it's coffee break time. I'll come up with another wise move here. Okay, I never actually made it to the coffee. Well, what if I just push this wire back against there? How would that do to the sound? Now I have the antenna hooked up. I've switched up to a band. Actually, I was going to try to find a station. Who's become so shaky? Simply be the connection is very poor there. You can see how the sound tone changes with the varying the volume. Just looking for any station. Where are we here? Okay, so we're on the highest band now. So we want to come down 1, 2. We'll try here. Another one. Nobody? Go down one more.
De las cuales yo también quisiera saber las respuestas. La primera es de Cindy y Piero, desde Sudáfrica. Ellos escriben: después de un estudio y oraciones cuidadosas, hemos llegado a aceptar la verdad acerca del Shabbat del Creador y estamos preparados a seguir a Yahuwah, cualquiera sea el costo. Hemos aprendido tanto en los últimos años que ahora nos preguntamos si debemos rebautizarnos. ¿Cuáles son los pensamientos de WLT acerca del rebautismo? Me encanta esta pregunta. Me gusta el...
Oh, we're in a phono. Phono.
Dimos más verdades, es natural querer someterse al Padre en una forma completamente nueva y más profunda. Por lo tanto, ¿qué dices? ¿Es necesario ser rebautizado?
Bueno, no estoy seguro realmente de ponerlo en esos términos. ¿Es necesario ser rebautizado? Esto es como una cachetada al legalismo. El bautismo es un privilegio. Sin embargo, ¿existen circunstancias cuales son deseables de ser rebautizados? Sí, algunas veces la hay.
Muy bien, bastante justo.
What? I just discovered a bad solder job from a couple of years ago. This wire just came right off. It wasn't actually soldered. Now, it was probably making contact, but you notice when I was doing this, there was nothing happening at all. Tell me this is actually the problem. The wire was not soldered. Could that be the problem? Radio's off now. Yes, it's off. You solder this wire back on and then everything works. It doesn't want to solder. My solder is elsewhere. Okay, I'll stop the video. I'll solder that wire. We'll try it with. Oh my gosh. Okay, let's give it a go here. Now, got the wire soldered in at that end, for sure. The other end I have brought into contact with its terminal, but it's just in contact. It's not soldered yet. Want to experiment a bit? Well, that answers that question. There's some kind of oscillation at the high end. Turn it down that way. So I turn the volume way up. What I hear is at some point something happens and things change, as if something started up. So turn up the volume, something happens. Turn it back down, something goes away. Even though you can hear the guy talking the whole time. So I think there is another oscillation in there still. So did this do anything here? Oh boy. Oh, danger on the solder. Oh boy. It's all coming back to me now. I'm starting to remember all kinds of stuff here. Yeah. Not helpful, huh? Well, wow. That's another fine mess I've got myself into here. So the effect of this wire is completely different than what I would ever have imagined. It looked like in the middle of the volume setting, putting the wire on generated a hummy type sound, but at either extremes it seemed to have no effect. Oh boy, I'll never be able to explain any of this, ever. For all I know, these are correct behaviors, just off a little bit, or perhaps they're totally wrong behaviors, the humming and the feedback. In other words, the humming and the feedback and stuff like that just caused from small variation in the resistance of the volume control. It's just like a minor thing is causing this, or something really major, like a component in wrong, which I spent a lot of time figuring out is not the case. Oh my gosh. The radio is almost usable as long as you don't want to turn it up or turn it down. Oh my gosh, I don't know what to do here. Stop and think about it. Stop and come up with some reasonable next step. Oh, I've come across something here, but I don't know what to make of it. So this is a diagram I made 2 years ago as I was trying to sort out probably exactly the problem I'm trying to sort out now. And I think this might have been the moment where I concluded the volume control itself was defective. And then I replaced it. So this diagram was made with the original volume control in place. True? I'm not sure. But here's the thing. See this red wire on my diagram going from here to the output terminal of the potentiometer here. That's this red wire. But you know what? It doesn't go to the output or the sliding part of the potentiometer. It's going here. It's going here. Well, what about these parts? These parts are going here. What? Wait a minute. Something's not right here. It looks like either in this diagram, for some reason, I've got these backwards, which is hard to understand how you'd make a diagram backwards. But hooking it up backwards, I got lots of skill in that department. It looks like I've hooked up these wires backwards. And then how could the radio even work? I don't know. Oh my gosh. So I'm going to look into this a little further before I start hacking and chopping, but that's pretty curious. I think I've mentioned the guy with 2 watches, never knows what time it is. Wow. Take a look at this. We see the volume control. You see the 3 terminals and the volume control. The center terminals here. Clearly it's hooked up to a resistor here and a small capacitor. If we look on my diagram here, my mysterious diagram from 2 years ago, the capacitor and resistor are shown here. I did raise some questions about the capacitor, but they're shown connected to a different terminal. So we got this, and we got this. What about the actual schematic? The slider on the volume control comes out and meets up with 2 capacitors. No resistor. 2 capacitors. 2 capacitors. No resistor. Where's the resistor supposed to go? So I'm not going to go into this in great detail. This is a 220K resistor. The 220K resistor is this guy down here, number 10. You can see it is connected to the top, but not the slider. To the top. To the top. So I got this version, I've got this version, and I've got this version. I don't know. And how, what, why? I don't know, but I'm going to run away and think about this some more. Okay, didn't take a lot of coffee or thought to figure out what to do here. So I have a situation, I made that situation. I have a diagram, I made that diagram. I have a schematic, a qualified engineer made this schematic. I think I better follow this schematic. So for some reason, and I don't know why, this is not done the same way as the schematic itself. And it could be I made this diagram, with the old part in there, and I made mistakes on the diagram, I guess. It's hard to believe I did, but somehow I made mistakes on it. And then I followed those mistakes to create this, making even more mistakes. Say, I have mistakes of the mistakes. Maybe if I just continue on, eventually I'll go right around the loop and my mistakes will lead back to something correct. Now, my only rational approach is to try to make the radio match this, even with this wrong volume control. Now, how wrong is it? The volume control that is in here, that the original one is a 1 megohm volume control. This is a 1.3 megohm volume control. You know, that's not dramatically different. The position of the tabs, it could be a little different. The tabs, I'll call them tabs. Okay, so that's what I'm going to do. I'm going to concentrate on trying to make this match this exactly, and that'll cause me to make another one of these and another one of those, and I'm going to fill up my coffee cup again because I can see what's coming. One of the things about doing these videos essentially live is that when I make mistakes, I can't hide it or whatever. Looks like it could be all that's wrong is this resistor was connected to the wrong terminal on the volume control. I've moved it over. Everything appears to match the schematic at this point. You know what? Except for one thing. There's still one thing that's not correct. There should be 2 capacitors tied onto this terminal, this middle volume control terminal. 2 capacitors. I only got 1. Yikes! C32 and C33. 32 and 33. Let's see them here. 32 and 33. That's the volume control that I've hooked up to. Right. Well, there's a resistor tied to 33. A resistor tied to 33. This diagram, 34. Anybody see 33, 31, 30. 33. Where's 33 on here? 32. Well, there's no 33 on here. It's 33K over here for a resistor. Oh, okay. Okay. Better take another coffee break here. So, I'm losing it. 32. 33 is connected to R13. R13, according to this, 10 megohms. Oh, that's easy to spot. I know where that is. That's a 10 megohm right there. So we're coming over, we're tying onto this capacitor, which is coming over to ground. So you have this resistor going to ground. That doesn't sound right, does it? Going to ground. No, maybe not going. Yeah. Going to a grounded terminal. Okay, I'm not going to carry on because this is going to drive anybody watching this just nuts. It's driving me nuts. See if I can sort this out. Okay, now I remember what I did. So the 2 capacitors are there. One is sitting here, and the other one's installed over here. Okay, so you know what? It could be just moving this over. That's the whole problem. That's the whole problem. So let's start this radio up here. Volume part way. Here we go. Okay, dim bulbs behaving normal. Are we going to hear anything? Ah. Apparently moving that resistor resistor doesn't make any difference. I'm worse off.
So the calendar of creation. You have new moons on the papal Gregorian calendar in use today. Okay, we've got time for just one more quickie. For a store approach over here in England. I find your name intriguing. You call yourselves World's Last Chance. Yes, thank you for that. Thanks for getting in touch. The name World's Last Chance was chosen for our website because it reflects our beliefs. Every one of our beliefs rests upon a solid foundation of Scripture. In the last chapter of the last book of the Bible, a warning is given.
This one. I think that's 9330. We're listening to it.
Still, words announce the close of probationary time.
Wow.
Can you take a moment to explain what you mean by probationary time? Yes, of course.
That's a hint. That's a hint. The situation got worse. Okay, phono. 4, 3, 2, 1, off. So we're on position. Where'd it go?
Or join.
Well, it's affected by the switch here. Oh my gosh. I don't know. Okay. Stop and try to find another thing that doesn't seem to add up here. Okay, maybe I should title this video Embarrassment Number 1. Look at this. So I've been tracking the circuits around, checking components, making sure that I didn't make a mistake in the work I did in here. And I finally got up in this area here. Which, sorry about the way this is lit. Just behind this resistor is a capacitor I installed. You can just see it right there. I installed it, but you know what? I never soldered it in. It's not soldered. It's loose up here. Really loose. Soldered on the bottom. It's even soldered on the bottom. Yes, but not on the top. Well, is that the problem? I don't know. I don't know, but I gotta fix that. Okay, I'm gonna solder that in, and we're gonna test the radio again. A little bit surprising to me that a loose component like that didn't show up as a, some kind of crackle or something in the operation of the radio. I could have found it long ago. Here we go. Here we go. Once again. Volume turned down. Okay, full power. Any smoke? Any smoke? No smoke? Some of that. What's happened here? We got no sound now. Come on. Are you kidding me? Oh, no antenna. No antenna. No antenna. I am kidding me. Okay. Put it on here. Oh boy. What is going on? We're going downhill. We're going the wrong direction.
In heaven. So we're gonna.
Hearing some weird clicks out of this radio. Anybody else loose in here? So it could be the station we're listening to is fading in and out at the same time I'm doing this. Don't anybody move.
But I'm afraid that if the person deceived these by his practice and purity,
Really?
majority of Christendom and Judaism and Islam have been led away from
I'm going to guess what happened to me is the last time I worked on this, and I got up to 50 videos on it, which means probably 75 hours or more. I was so frustrated that, in fact, I just stopped working carefully and just started getting reckless. And I don't want to be reckless. Power's off. I don't want to be reckless. Now, how can this be not soldered? Somebody's not soldered in here. Got a whole bunch of components on this terminal. Who's not soldered? It would be this one right here. This is the feed. This is the this wire I'm holding is the feedback line that comes right from the output transformer. This is the original feedback, negative feedback line. Well, let's stick this in here and actually solder it, and then we'll see what happens. Because that seemed to be it. This is, why all the weird behaviors, and I don't know. Okay, we can solder that. Power's off. Oh man, my own bad work. Yeah, you know what? A large percentage of my time is spent correcting my own bad work. That's why it's a good thing I'm not a doctor. Yeah. But let's put it this way, the patients that I doctor, they really don't matter anyway. Just a radio. Okay, everybody seems to be soldered in there happily. Is this the problem? Was that the problem? Let's get rid of this solder before it shorts something out. Okay. Volume's down. Power's going on. Bad soldering. Boy, oh boy, oh boy. Full power. Oh no. Engine's running. Well, it really sounds like the AVC is involved with it. Most of the time, motorboating is AVC action involved. Well, what's going on here? How come? Well, did I just solder together a really good wrong connection? Is that what I just did? And when the wire was loose, things worked better? There's no volume coming from the radio anymore. Snap switch. Okay, I'll go right this way. Off. First setting. It's worse than ever. Cheapers creepers. How can this be? You can hear the radio now, but just barely. Well, I must be getting close to the problem. Where did the volume go? So much feedback now, the volume is completely nullified. Oh my gosh. That was not what I was expecting at all. Oh my. Okay. Well, you know what? I think I'm going to leave it here for today. Unfortunately, I don't have the feeling I'm, one more move away from success. I don't feel that at all. I think there's a lot to sort out here. There could be multiple problems generated by who. And working through them all, it's just I see I replaced resistors over here. There's potential for me having introduced an error here is so high. Oh my gosh, and this is one of my favorite radios. Come on, Jim. Okay, well, thanks a lot for watching to this point. If the weather's bad, I'll be back in here tomorrow, and we'll just pound away on it. Thanks a lot for watching. See ya.